Just 1 second.
Sir, actually there was some lag. So actually now we are live.
Okay, sir. Sir, shall I start from here? From beginning?
Yes, sir. Yes, sir.
Hello students, welcome to the GATE Score booster session of digital circuit subject. Good morning to one and all. All of you please respond to which branch you belong to. The subject digital circuits is one of the most important and scoring subject as per GATE exam point of view. This subject is common for 4 branches: EC, electrical, instrumentation, and computer science. Right. So in this session and tomorrow's session also, we will cover all the important and most important concepts of entire digital circuit subject. Okay, through which you will get the revision of entire digital circuit subject, and you will get the problem solving, how we can solve the digital questions in less time. All the tips and techniques you will learn from these 2 sessions, right? Yeah, very good morning. Yeah, EC, CSC, yeah, students are there. Yeah, all of you please share this video with all of your friends so that they also can attend this particular session live, and they also will get benefited from this particular session, right? I will introduce myself briefly. I am Jay Prakash. I have done MTech at NIT Calicut. My specialization is electronic design and technology, that is embedded systems. I am working as subject matter expert in the GATE Academy Bangalore from last 2 years. And I am having overall experience of 5 years in the GATE domain as content developer and faculty. My favorite subjects are digital circuits and network theory. So today and tomorrow, we are going to discuss related to digital circuits. Okay. I hope all of you are eagerly waiting for the session, right? Are you ready? Yeah, all of you please respond. First read the question. Either you can take the screenshot of the question. Okay, in order to save the time. First read the question and tell me what are the concepts involved in this particular question. What are the concepts involved? This question belongs to which chapter? Yes, number systems and codes, right? See, what are the first chapter title is there? Number systems and codes. Here in this, with the help of this question, we have covered all the concepts. See here, you're having decimal number, hexadecimal, binary. Okay, and the answer he is expecting in hexadecimal, and in between gray code, right? So that means we are discussing the number system conversions and gray code also. So first read the question. If 2030 base 10 exclusive or EBCD base 16 equal to Y base 2, then the equivalent gray code of Y in hexadecimal representation is. So first, what you have to do, convert this decimal number into hexadecimal. In order to convert decimal into hexadecimal, what you have to do? What is the procedure? How we can convert decimal number into hexadecimal? Either repetitive division or repetitive multiplication. Which method we will follow? Decimal number into corresponding hexadecimal number. Repetitive division, right? When you do the repetitive division, then only you will get the hexadecimal digits, right, as the reminders. No, since it is a decimal number, first we'll convert into hexadecimal. From there, you can convert into binary, right? So do the repetitive division with 16. 16 ones are 16, remainder is 4, 43. 43 is nothing but, so you can do 2 16s are 32. Remainder you'll get 11. 110. 110 means you can do the division with how much number? 16 6 are 96. Remainder you will get 14, that is nothing but E. remainder you will get 14, that is nothing but E. Next, 16 sevens, here also you will get remainder is 14, that is nothing but E. 16 zeros are 0, remainder is 7. Now, whatever the digits you are getting here, whether we'll consider the reverse order, that means down to top, or we'll consider top to down. In which order we will consider? Reverse order, right? Yes or no? Reverse order. Down to top. Yes, very good. Very good, Michael. Michael, Sweta, yes. So that means 7EE. 7EE is the corresponding hexadecimal number for the decimal number 2030. 2030. Right? Whatever the remainder you got last, that will be your starting digit while you're writing from left to right. Left to right. Okay. So 7EE is the corresponding hexadecimal number for decimal number 2030. Here you're having one more hexadecimal number EBCD. Right? So, but here you're having only 3 digits. What we can do? What we can do? In order to represent with 4 digits, what we can do? Here we are having only 3 digits. What I can put? The 4th digit. 0, right? If you put 0, the equivalent value won't change. Okay. Now, in order to convert hexadecimal into binary, how many bits we require? In order to represent each and every hexadecimal digit in binary, how many bits we require? 4 bits. Very good. 4 bits. Represent each and every hexadecimal digit with 4 bits. 0 is nothing but 4 zeros. 7 is nothing but 0, 111. E is nothing but 1110. And once again E, 1110. Now consider the other number, that is EBCD. EBCD base 16. Here also represent each and every hexadecimal digit with 4 bits. E is nothing but 1110. B is nothing but 1011. C is nothing but 1100. And D is nothing but 1101. Now you have to perform exclusive OR operation. Among these two numbers, right? So when you will get the output as 1 for 2-bit case, when you perform exclusive OR operation, in which cases you will get output as 1? Odd number of ones, that is a generalized case. When you're having 2 bits for 0-1 case or 1-0 case, for these 2 cases only you'll get output as 1, right? Yeah. For generalized case, odd number of ones. Okay. Even it will applicable for 2 inputs or 3 inputs also. Fine. Since you're having only 2 inputs, if the bits are not same, then output you will get 1. If the bits are same, you will get output as 0. So like that, 0 XOR 1 is 1, 0 XOR 1, 1, 1, 0 XOR 0 is 0. Like that, continue the process. All of you write the corresponding XOR output. 1, 1, 0, 0, 0, 0, 1, 1, 0, then 0, 0, 1, 1. Right. So this is the binary code. Now in the question, what he is asking, the corresponding gray code. This one he has represented as y base 2. Okay. He is asking the corresponding gray code. In order to convert binary to gray code, what is the first step? Yes, very good, Supriya. Very good. While doing the conversion of binary to gray code, what is the first step? Yeah, we'll copy the MSB as it is, right? Whatever the starting bit is there, you have to copy that bit as it is. Whatever may be the number of bits you might be having in the binary code. This is the starting step, first step. Whatever the MSB or starting bit you're having, copy as it is. After that, perform exclusive OR operation on successive bits. 1 XOR 1, 0. 1 XOR 1, 0. 1 XOR 0, 1. Like that, perform exclusive OR operation on successive bits. 0 XOR 1, 1. 1 XOR 1, 0. 1, 0. 0. 0. 1. 1. 0. 0. 1. 0. So this is the gray code corresponding to the above binary code. This is the gray code corresponding to above binary code. Now he is asking the corresponding hexadecimal representation. Reverse. See, previously we have converted a hexadecimal to binary. We have represented each and every hexadecimal digit with 4 bits, right? Now, if you do the grouping of 4 bits, you will get the corresponding hexadecimal digits, right? So what is the number you will get? All of you please respond. You are very much familiar for 4-bit case. Now tell me what is the corresponding hexadecimal number you will get. Hexadecimal number. Yes, 9832. Very good. 9832. Base 16. 1001 is nothing but 9. 1010 A 0011 3 0010 2. 9832 base 16. So that means option D. Option D is the correct one. Right. So here we have solved the question completely. If you observe here, it is the multiple choice type of question, right? So whenever you are getting multiple choice type of question, obviously there will be alternative method. As the name implies, choice is there for you, right? While solving the question, in order to get the answer in less time, definitely you will get, if you follow the other method, there will be alternative method, obviously, okay, in order to get the answer in less time. So whenever you're having multiple choice type of question, instead of solving the entire question, what you can do, after reading the question, just look at the choices. From there you will get the tip or technique through which method, if you follow, you will get the answer very quickly. Just observe here in all the 4 choices, just observe the starting digit. You're having 8 in 2 choices and able to eliminate 2 choices. After that, last digit is varying 4 and 2, right? So in this process, first you try to find regarding the starting digit and then last digit. Regarding hexadecimal digit, I'm talking. Here 0 XOR E is nothing but what? 0 XOR E. What is the value you'll get? 0 XOR E. It is similar to 0 XOR X. 0 XOR X is X, right? So similarly, 0 XOR E is E. You will get E, right? So that means here you will get E, that is nothing but 1110. Okay. Like that, you focus the last one also, right? And from there, if you just calculate the starting digit and the last digit, with the help of those two, you can get the answer very quickly. Intermediate steps you can ignore in order to save the time. Is it clear, all of you, regarding binary to gray code conversion? So here in this particular question, we have done the number system conversions, and then we have found the gray code, and then we have converted back into hexadecimal, because in the choices they have mentioned in hexadecimal format. Okay, right. Now let us proceed to another question. All of you please respond. This question is related to which concept? This is one of the most important concepts in the first chapter. One important concept is number system conversions. Another important concept is this one. What is this one? What is the concept involved here in this particular question? Data representation, right? Data representation or representation of numbers in binary. Yes, very good. Very good, Srinivas. Right. So just read the question. If P equal to 11101011, the same number is there, but he has labeled as PQRS, or in unsigned category, sign magnitude, 1's complement and 2's complement form respectively. Then the number of bits that are required for representing 2's complement of P minus Q plus R minus S is dash. Okay. See, everything will represent in terms of binary only. That means in terms of ones and zeros. But based on the context, the answer will vary. The corresponding decimal equivalent, it will vary. So all of you please write the given four numbers. The same number only, but he has labeled as PQRS. And he has considered as different notations. Different notations. So here the number is 11101011. The same number, copy once again for all the four numbers, for all the four cases. 11101011. Okay. Now P is corresponding to unsigned case. Unsigned. In unsigned case, all the bits give the magnitude. In unsigned case, all the bits give the magnitude. That means when you do the grouping of 4 bits, you'll get the corresponding hexadecimal is, that means P is nothing but EB. EB base 16. Now tell me what is the corresponding decimal number. All of you please calculate and tell me what is the corresponding decimal number. You can calculate the corresponding equivalent value by placing the position weights in powers of 16 and multiply each and every digit with the corresponding position weight and then add. Yes, 235 you'll get. Right, very good. Very good, Srinivas. 235. 235. Right. So if you consider this particular 8-bit number, if it belongs to unsigned category, then the corresponding decimal number is 235. Very good. 235. Next, if you consider this Q number, Q is in sign magnitude case. In sign magnitude case. In the sign magnitude case, the starting bit is corresponding to sign bit and the remaining bits give the magnitude. In the sign magnitude form, the starting bit is reserved for sign bit and the remaining bits give the magnitude. Since the sign bit is 1, whether it is negative number or positive number. If the sign bit is 1, whether it is positive number or negative number. Negative number, right? Very good. If the sign bit is 0, it is a positive number. If the sign bit is 1, it is a negative number, right? So that means you will get resultant value is minus. Okay. Now remaining bits give the magnitude. 110 is nothing but 6. 1011 is nothing but B. This is the hexadecimal number. Convert this number into decimal. Convert this number into decimal. It is very simple calculation. All of you please do. So that you will get practice, right? If you're practicing here in this live session, definitely all these concepts will be in your mind. Okay. You never forget. You don't need to do additional practice after attending this session, right? Yes, very good. Minus 107. Minus 107. Minus 107, right? Next, R number, if you consider, he has mentioned in ones complement form. Ones complement form. Right? Ones complement form. So here also, whenever they mention this particular number is represented in ones complement form. Okay, the starting bit, sign bit is 1. So because of that, you'll get negative number. Okay. In order to get the magnitude of this number, what we have to do? Tarun, well tried, but that is not the correct one. You can cross check once. Well tried. In order to get the magnitude of this particular number, what you have to do? You have to apply once again ones complement. Yes or no? If you apply once again ones complement, you will get the magnitude of that number, right? So what you will get? 0001, then 0100. 0100. See, whenever they mention one particular number is represented in ones complement form, you have to observe the starting bit. If the starting bit is 0, it is a positive number. If the starting bit is 1, it is a negative number. If the starting bit is 1, Then you have to apply ones complement to this number. From there you will get the magnitude. From there you will get the magnitude. If you are having starting bit as 0 in ones complement form or twos complement form, whatever the remaining bits, that will give the magnitude directly, just like in sign magnitude case. Okay. So here you will get minus 14 base 16. That is nothing but minus 20. Now, another number, this is represented in twos complement form. Now tell me, what is the number you will get? The corresponding decimal number. Any idea? If this particular number is represented in twos complement form, what is the corresponding decimal number? Yes, very good, Shweta, Michael. Yes, minus 21. See, just observe here. You're having 8-bit number like this, and he's asking what is the corresponding equivalent decimal number, right? So for this entire number, whatever the equivalent value you will get, the same number you will get if you consider these 6 bits. For the timing, I'm writing once again 101011. If you consider these 6 bits, whatever the decimal equivalent you will get, the same number you will get for the entire number, because if you consider this particular number, sign bit is 1. To the left of this particular sign bit, he has placed simply 2 more times. N number of times, even if you put the same sign bit to the left of the sign bit, the equivalent value won't change. Right? This is the sign extension property. Now, in order to get the magnitude, you just place the positional weights in powers of 2. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5. Since the sign bit is 1, I will consider minus because it is a negative number. Right? Now, add the positional weights wherever you are having ones. Respective positional weights you can add. Minus 2, 1011 is nothing but 11. So that means you will get minus 21. The same number you are getting, right? And one more observation. Here you are having 11101011. Here also the same number. Just by looking at the sign bit, it is an 8 number. Okay. So in ones complement form, since you got minus 20, obviously, if you consider the same number in twos complement form, in negative case, you will get one number extra. Negative side. Okay. So that means you will get minus 21. What is the reason? Any idea? Why will get one value higher when compared to this one? For negative number case. See, in sign magnitude case or ones complement case, for plus 0, minus 0, you're having 2 different representations. Whereas in twos complement form, you're having unique representation, right? So that's why here we'll get one negative number extra in twos complement form. Right? So that's why here it will be minus 21. If the same number is there in ones complement form, what you can do, first you will get minus 21. If you're adding 1 to it, then you will get minus 20, like that. Either like this or like this. So now you have to find P minus Q plus R minus S. Just 1 second. P minus Q plus R minus S. So now write P plus R. This one we can write as P plus R minus, if you take common, then you'll get Q plus S. Right? So just substitute here 235 base 10 plus R is nothing but minus 20 minus Q is nothing but minus 107 plus S is nothing but minus 21. Do the simplification. What is the number you will get? What is the decimal number you will get? All of you please respond. What is the decimal number you will get? $343, right? Do the simplification. It is very simple calculation, right? All of you please cross check. You will get 343. Yes, very good. Very good, Shweta, Michael. Yeah, Srinivas, you can cross check. You will get 343. 343. Now, what he is asking? 2's complement of this number. 2's complement of this number, right? So that means 2's complement of 343. 2's complement of 343. That is nothing but what? Minus 343. 2's complement of 343. That is nothing but minus 343. That means if you are applying 2's complement for positive number, you will get negative number. If you are applying 2's complement for negative number, it will become positive, right? Like that, vice versa. 2's complement of positive number, that means you are getting negative number. Okay. Now, for representing minus 343, how many bits you require? That is the question. Whether anyone tried? For representing minus 343, how many bits you require? See, conventional method I am not discussing here. That you can, if you want, you can just verify later. Whenever you want to represent negative numbers in 2's complement form, what you have to do? Consider the magnitude. Magnitude of this number is 343. Magnitude of this number is 343. First, represent this number in unsigned category. After that, consider positive number in sign magnitude form. Okay. Whatever the representation you are getting for positive number in sign magnitude form, the same representation is valid in other two also, in 1's complement, 2's complement also. Now, in order to represent minus 343 in 2's complement form, you have to apply 2's complement to this one. Then you'll get 2's complement representation of minus 343. 2's complement representation of minus 343. So this is a conventional method. If you want, you can do later. For the timing, I'm not doing like that. Okay. So I will give the shortcut method only. Yeah. See here, just observe. If you understand this question, if you understand this part, okay, what are the logic involved here? If you follow the same logic, you will get the answer very quickly. Just observe here. Suppose you are having 6 bits. These 6 bits are represented in 2's complement form, right? So since sign bit is 1, the corresponding positional weight I have considered minus. That means the overall equivalent value of this particular number is what? Negative. So that means in order to get negative number, the starting bit should be 1 and the corresponding positional weight will be minus. Okay. Now all of you please respond. You have to consider one positional weight, okay, in such a way that which should be power of 2, and its equivalent value, when you calculated that particular value, it should be greater than or equal to 343. Like that, whatever the least positional weight that is satisfying, that I will consider. Which positional weight we have to consider? In such a way that least positional weight will be greater than 343. See, if you take 2 power 8, then it will be 256. 2 power 8 is 256. So this number is smaller, right, when compared to this number. I am talking about only magnitude. 2 power 9 is 512. The least positional weight, which should be greater than or equal to this particular magnitude of this number, that one we will consider, right? Yes, 2 power 9. Very good. 2 power 9. So that means here, when you're having 6 bits, the position weights are what? 2 power 0, 2 power 1, 2 square, like that, up to 2 power 5 you're getting when you're having 6 bits, because we are starting from position weight 2 power 0. Similarly, if you want to get 2 power 9, the position weight, that position weight I will consider minus. Because the sign bit is 1. So in this case, how many bits you're having? Since the position weight is 2 power 9, total number of bits are how many? How many bits you will be having? Total number of bits I'm talking. For representing this particular number, total number of bits, how many you require? See, you can follow the same approach. Here 2 power 5, that means total bits are 6, right? Here you are getting 2 power 9, that means total bits are 10. Yes, very good, Srinivas. 10 bits. Yeah, sometimes students will say 9 bits. No, because we are starting from 2 power 0, 2 power 1, 2 square, 2 cube, like that. The highest position weight here 2 power 5. Total bits are 6, right? Similarly, here position weight is 2 power 9. That means total bits are 10. 9 plus 1 is 10, right? Is it clear, everyone? For representing minus 343 in 2's column form, we require 10 bits. Yeah, answer is 10. Yes. We have to consider total number of bits, right? Since the sign bit is 1, it is an 8 number. In order to get the overall equivalent value, you have to consider the sign bit also. Total number of bits are 10. Later, you can solve this conventional approach. Okay. From there, you will get one number in terms of ones and zeros. There, if you calculate, the minimum number of bits required is 10 only. Okay, we'll proceed for next question. All of you take the screenshot of the question. A number n in 2's complement format is xxyz. He has given a 4-bit number like this, xxyz. Okay, it is transformed to xyz11 in 2's complement format only. Okay, the corresponding decimal equivalent. This is equivalent to which of the following operation? He has given 4 choices. We have to find which one is the correct. So for the time being, I am considering a 4-bit number like this, 1100. What is the corresponding decimal equivalent? This particular number is represented in 2's column format. What is the corresponding decimal number you will get? All of you please respond. For the timing, I have assumed like this, 1100, because here the format is xxyz. That means these 2 bits are same. Here yz. If you want, you can consider different also, no problem. For the timing, I have considered 1100. It is represented in 2's column format. See, you have to read the question very carefully, especially when you are attempting the questions related to 2's complement. Read the question very carefully, right? If they don't mention to which format it belongs to, by default, you will consider unsigned case. Then 1100 is nothing but 12. That is correct only. But here they have mentioned 2's column format. Yes, very good, Srinivas. Priya. Yes, very good. So here, just you put the position weights 2 power 0, 2 power 1, 2 square, 2 cube. Since the sign bit is 1, the corresponding position weight is minus. Okay, so minus 8 plus 4, that is nothing but minus 4. Or in other words, this entire number equivalent value is same as this number. Since the sign bit is 1, the corresponding position weight I will consider minus. Minus 2 square is nothing but minus 4. Either of the method you can follow, no issue. You will get minus 4. Right. Now consider this number xyz11. So substitute the corresponding values. X is nothing but 1, y value, z value is 0, 0, 1, 1. Now this is also in 2's column format only. What is the equivalent value? What is the decimal equivalent? This is also represented in 2's column format only. What is the corresponding decimal number? Yes, very good. Minus 13. Right. Similar approach. 2 power 4 is 16. Minus 16 plus 3. That is nothing but minus 13. Right. Now, here you are getting the resultant value as minus 13. Here in this case, n is nothing but minus 4. Now, just verify option by option. First, let us consider option A. Whichever option satisfies, that will be the answer. Okay. So 2 into 2n, that means 2 into minus 4 plus 3 by 2. So 2 4s are -8. -8 into 2, that is -16 plus 3. That is nothing but -13. You are getting option A. Yes, very good. Option A is the correct one. Yes, Tarun got option A. Yes, very good. So you have to be very careful whenever you are supposed to write the corresponding decimal numbers, right? See, everything they will represent in terms of ones and zeros only. Based on the context, the equivalent value will change. The equivalent value will change. Suppose the same 1100 is there in sign magnitude case. Sign magnitude case. What is the equivalent value? Sign magnitude case. If 1100 is in sign magnitude form, what is the decimal equivalent? Not -8. See, 1100. If it is sign magnitude case, this bit is sign bit, remaining bits give the magnitude. So that means -4. -4 in sign magnitude case. Right? Yes. The same number, if it is in ones complement form, what is the equivalent value? If it is ones complement form, what is the equivalent value? -3. Yes, very good. -3. -3. In this way, if you observe for negative numbers, you will get different representations in sign magnitude form, ones complement form, twos complement form. Whereas for positive numbers, whatever you get in sign magnitude form, the same representation is valid in other two also, in ones complement, twos complement form. Okay, you have to read the question very carefully. Based on the context, you have to follow accordingly, right? Twos complement representation, twos complement of some number, both are different. Okay. Yeah, next question. Read the question. What are the concepts involved in this particular question? Please share. What are the concepts involved in this particular question? This is a question related to which chapter? You can tell either chapter name or the concepts involved in this particular question. Yeah, here, yeah, in order to get the simplified function, we will use K-map. Yes, very good. Very good, Priya. Here we are having sigma m format, pi cap lem, and here we are having dual, right? Yes, Boolean algebra and K-maps. And here we are discussing about min terms, max terms. Sum of min terms are product of max terms, right? So sigma m format you're having, pi cap lem. Okay, if you do the simplification of sigma m, which form you will get? If you do the simplification of pi cap lem, which form you will get? In general, for most of the questions, after doing simplification of sigma m, which form you will get? After doing simplification of pi cap lem, which form you will get? Yes. So first one is SOP form, second one is POS form. Very good. Very good. Right. So if you observe the given function, here what he has mentioned, choose the correct option or options of the Boolean function. He has given one function like this, and he has given 4 choices. We have to pick up all the correct options. Okay. So just observe this particular function. This function is in which form? All of you please respond. It is a function of 4 variables, and look at this particular function and tell me this particular function belongs to which form? SOP, right? Yes, very good. SOP form. SOP form. Because here you're having product terms sum together. That's why it is SOP, sum of products. Okay. And in each product term, how many literals you're having? In each product term, how many literals you're having? 2 literals, right? Literal is nothing but variable normal form or complement form. Okay, you're having only 2 literals, but it is a function of 4 variables. It is a function of 4 variables. If in any product term, if the number of literals and number of given variables both are matching, then we will call that particular product term as min term. Otherwise, we will call simply as product term. That's all. Okay. So that's why it is SOP form. SOP form. Now from SOP form, see the forward approach is what? Suppose if you're having sigma m format, if you do simplification, you'll get SOP. If you're having pi capital M, after doing simplification, you'll get POS. Okay. Similarly, if you want, you can do the reverse also. If you're having SOP form, you can convert into sigma m. If you're having POS form, you can convert into pi capital M, like that. Once if you know sigma m, you can convert into pi capital M, or from pi capital M to sigma m. Like all these conversions in any direction you can do, right? Yes. So now let us convert this SOP form into sigma m format by using shortcut method. So first write the variables ABCD. Whenever you write the min terms or max terms, the order of the variables is very, very important. The order of the variables. In this particular function, he has mentioned ABCD are the variables. That means A is the MSB, and D is the LSB. Whenever you write the min terms or max terms, the order of the variables is very, very important, right? If you don't follow that given order, then obviously your answer may or may not correct. For most of the cases, it won't correct, but in exceptional cases, it may valid. Okay, but you have to consider always whatever the order he specify, you have to consider. Sometimes they may not mention in the given question. If they don't mention which variable will be the MSB, okay, for generalized case, this one you can follow. Suppose if you're having alphabets, ABCD, among these alphabets, A is the starting letter, so A will be the MSB. Suppose sometimes they will mention the numbering A3, A2, A1, A0. In that case, the higher order number is 3, so A3 will be the MSB. This is the standard notation. Whenever they don't specify in the question which particular variable is the MSB, you can follow this notation. If they specify, suppose if they want, they can specify f of DCBA also. In that case, D will be the MSB, like that. Whichever order they will specify, will consider strictly that order. If they don't specify, this is the convention you can follow, right? Yes. Now, consider term by term. So first one is what? AB. So AB means A value 1, B value 1. Just substitute here. You should get output as 1. Simple. Whether you consider sum of products or sigma m format, in order to get output as 1, like that you have to consider the variable values. Okay. Here C and D, these two are missing. So you'll get 4 combinations regarding CD. Write all the 4 combinations. Now tell me what are the corresponding min term numbers? Yes, 12, 13, 14, 15, right? Very good. 12, 13, 14, 15. Next, consider other term, that is A C bar. That means A value is 1, C value is 0. Here in this case, B, D are unknown, right? So regarding B and D, consider 4 combinations: 0, 0, 0, 1, 1, 0, 1, 1. For these 4 combinations, A value remains 1, C value remains 0. Now tell me the min term numbers. 8, 9, 12, 13, right? Not 10, 11. It will be 12, 13. Yes. Very good, Shweta. 8, 9, 12, 13. Next, consider the last term, that is BC bar. That means B value is 1, C value is 0. Here A and D, you will get 4 combinations: 0, 0, 0, 1, 1, 0, 1, 1. For these 4 combinations, BC value remains same, 1, 0, 1. Now in this case, what are the min terms? 4, 5, 12, 13, right? 4, 5, 12, 13. Yes, 4, 5, 12, 13 you will get. Just cross check. Some students are getting different for last 2 cases. Please cross check, right? So in this way, you will get the min terms. Okay. After that, you have to sum Sum of minterms. What is the representation? Sigma m format, right? F of ABCD, F of ABCD equal to sigma m format. So write the minterms 12, 13, 14, 15. Okay, if any minterm repeats, you can consider one time. Here 12, 13, 14, 15 is there. 8, 9, just one second. 8, 9, 12, 13. 12, 13 is getting repeated. You can consider one time because x plus x is x, right? M12 plus M12 is nothing but M12. M13 plus M13 is nothing but M13, right? Similarly, here also it is getting repeated. You can consider one time. Now, what are the minterms you got? Write in the ascending order. Write in the ascending order. That means 4, 5, 8, 9, 12, 13, 14, 15. Is it clear, all of you, up to this step? Yes, very good. 4, 5, 8, 9, 12, 13, 14, 15. Right. Any doubt is there up to this step? If you're having any doubt, you can ask. Is it clear? Any doubt is there? Please respond. Yeah, clear, right? Yeah, very good. So now just observe option A, whether it is correct or not. 4, 5, 8, 9, 12, 13, 14, 15. The same minterms you got, right? So option A is the correct one. Option A is the correct one. Okay. Now, option B is what? Pi capital M. Pi capital M. Now just observe. If you're having these minterms, how you can write the corresponding maximum format? Pi capital M. Pi capital M. Since it is a 4 variable, you will get the range as 0 to 15. Within this range, other than these terms, remaining will be the max terms, right? Remaining will be the max terms. So that means 0, 1, 2, 3, 4, 5 is there, 6, 7, 8, 9 is present here, 10, 11, 12, 13, 14, 15, right? So these are the max terms, 0, 1, 2, 3, 6, 7, 10, 11. Yes, very good. Very good, Priya. Now, whether option B is correct? Whether option B is correct? Here 14 is there, here also 14 is there, right? Since this function is correct, this function won't be correct, right? Yes, because here you're having minterm 14, you should not contain the corresponding maximum, right? So option B is wrong, not correct. Okay. Now, option C is what? Equivalent minimized function of f of ABCD in POS form. In POS form. That means we have to consider pi capital M, and with the help of K-map. If you do the simplification, you'll get POS form. Whether that form is same as this form or not, we have to verify. So this is the pi capital M format we got. So all of you draw the 4 variable K-map and do the groupings. All of you draw the 4 variable K-map. Here the variables are ABCD. Variables are ABCD. Just one second. Here we'll place 0, 0, 0, 1, 1, 1, 1, 0. What is this particular code? 0, 0, 0, 1, 1, 1, 1, 0. What is this code? What is the name of this code? It is very popular, right? 0, 0, 0, 1, 1, 1, 1, 0. What is this code? Gray code. Yes, very good, Shweta. Srinivas. Yeah, gray code. Now, we are considering pi capital M format. Pi capital M format. So, in the respect to maximum positions, we have to place the zeros. If you are considering minterms, in the respect to minterm positions, we will consider 1. Okay. Since we are considering max terms, in the respect to maximum positions, we will place zeros. Okay. So, 0, 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11. That's all, right? So since you're having 8 max terms, 4, 2, 2, 8 max terms, right? Just place the zeros in the respective max term positions. Now you can do the grouping of these 4 zeros. What is the term you'll get? All of you please respond. Regarding this, what is the term you'll get? Yes, very good, Priya. A plus B. Yes, very good. Rajshekar. Shweta, you won't get complement. See, it is very simple. Why you won't get complement, I will tell you. See, when you're considering min terms, then if you are doing the grouping of these 4 zeros, then you'll get A bar, B bar, A bar, B bar. Because when you substitute 0, 0, 0 bar is 1, 0 bar is 1. Since you're considering min terms, output is 1. But here what you're considering max terms. Okay. When you substitute the values, you should get output as 0. 0 plus 0 is 0, right? So that's why here we want to consider the complement version, right? So just remember regarding min terms notation, exactly opposite you will follow the convention for max terms, right? Okay. So here both the values A and B are zeros. So the normal form A plus B. If you're having any doubt, simple. What are the values here you're having? Just substitute here. You should get output as 0 because here these are the inputs, right? A, B, C, D is the inputs. Here, whatever the K map you are representing the values, those are nothing but output when you're applying the corresponding inputs, right? So you should get. If you're getting accordingly, then there is no issue. Whatever the convention you followed, that is correct only, right? Next. Do the grouping of these 4 zeros. What is the term you will get? Grouping of these 4 zeros. A plus, not A bar, you'll get A. Because A value is 0 for these 2 rows, A value 0. That means A. For these 2 columns, C value is 1. That means C bar. A plus C bar. Right? See, if you're having any doubt, just substitute. A value 0, 0 plus C value 1. 1 bar is 0. 0 plus 0 is 0. Right? Similarly, do the grouping of 4 zeros like this. You can do combinedly grouping of these 4 zeros. Now, in this case, what is the term you'll get? B plus C bar. Yes, very good. B plus C bar. Very good, Srinivas, Supriya, Priya. Yes, very good. Rajshekar. Yeah. B value is 0. That means normal form. C value 1, complement version. Right. So here, after doing grouping of max terms, you will get some terms. You will get some terms. The next step is we have to multiply those sum terms so that it will be PYS form. PYS form, right? So f of ABCD equal to A plus B into A plus C bar into B plus C bar. Right. Now just verify whether option C is correct or not. A plus B is correct. Second one is you are getting A plus C bar, A plus C bar. But here what you are getting? A bar plus C he has mentioned, right? So this is not correct. So that means option C is not correct. Yes, option C is not correct, right? So up to now we verified for 3 choices, only option A is true. Now we have to verify regarding option D. Option D, whether it is self-dual function or not. What do you mean by self-dual? Any idea? What do you mean by self-dual? Yes, the function is having the corresponding dual also same, right? Very good. What are the function you're having after applying dual also? If you're getting the same function, then we will call that particular function as self-dual, right? So first write the given function, that is AB plus AC bar plus BC bar. AB plus AC bar plus BC bar. This is a given function. Now you have to apply dual to this one. You have to get the dual, you have to interchange You have to interchange logical and with logical or. You have to interchange logical and with logical or. If zeros and ones are there, those also you have to interchange. Okay, then only you'll get the corresponding dual function, right? So all of you just apply duality principle here. You'll get a plus b into a plus c bar into b plus c bar. See, here you're having logical and logical or will come. Logical and logical or. Logical and logical or. Here you're having logical or, that means you'll get logical and logical and. That's all. Now you have to do simplification, right? See, what you have to do in general, what you will do, you will multiply this term with these two, this term with these two, right? Like that you will do simplification. Now, yeah, if you follow like that, you will get the same answer. But just in order to save time, I will follow other one. Here you're having a plus something, here a plus something, right? So I will use distributive law from RHS to LHS. I will write here distributive law. X plus yz if you're having like this. Okay. By using distributive law, you can write as x plus y into x plus z. X plus y into x plus z. This is distributive law. Right. So sometimes we will use like this, left hand side to right hand side. Okay. Or sometimes I will use RHS to LHS, right? Just observe here, x plus something, x plus something. That means I will write x plus as it is, and then I will multiply these two. That means yz you will get, right? Similar procedure here, a plus something, a plus something. So I will write a plus as it is. After that I will multiply these two. That means b into c bar. B into c bar, right? Another term is what? B plus c bar. Okay. Now you have to multiply a with these two. Similarly, this term with these two. All of you do the simplification. AB plus AC bar plus BC bar plus BC bar. BC bar plus BC bar, don't write it as 2BC bar, 2 times BC bar, because this is digital class, right? X plus X is X only, right? So you can consider one time. So that means what you will get? AB plus AC bar plus BC bar. Now just observe whether this function and this function both are same or different. All of you please respond whether this function and this function both are same or different. Yes, both are same, right? That means whatever the original function you're having, after applying dual, you're getting the same function. That means the given function is self-dual. The given function is self-dual. Self-dual, right? So that means option D is also correct. Option D is also correct. That means among the 4 given choices, only 2 choices are correct, A and D. See, in the GATE exam, if the question is MSQ type of question, right? So whichever correct options, you have to choose all the correct options in order to get the marks assigned for that particular question, right? Suppose in this particular question, 2 choices are correct, but you have chosen only option A, then you won't get any marks for that question. You won't get any native marking also. There is no native marking for the MSQ type of questions in the GATE exam. And there is no partial marking also, right? If you want to get what are the marks assigned for that particular question, if you want to get the marks correct, what are the marks assigned, you have to choose all the correct options. Sometimes only one option can be correct, sometimes 2 options can be correct, or 3 options, or all the 4 options, right? So how many options are correct? You have to choose all the correct options. Then only you'll get the marks assigned for that particular question, right? Yes, very good, Srinivas. Very good, Saubhagya. Yeah, A and D are correct. Now, next question. This question is also of MSQ type. MSQ type. Identify the self-dual functions. Identify the self-dual functions. First, let us verify option D. All of you please try for option D. After that, I will explain for remaining 3 choices. Okay. All of you please verify for option D, whether it is self-dual or not. Just now we have discussed how to apply duality. After that, you have to verify whether it is self-dual or not. I will give the time. All of you please try regarding option D. First, you verify for option D. Apply duality and verify whether it is self-dual or not. Yes, it is not the self-dual, right? Yes, very good. So apply duality principle, you will get a bar plus b into a bar plus c into b plus c bar. Yes, very good. Most solutions got, yeah, it is not the self-dual. Very good. So here also just observe a bar plus something, a bar plus something. So I will copy a bar plus as it is, a bar plus as it is, then multiply these two. That means you will get bc, bc. Then you're having b plus c bar, b plus c bar, right? So multiply this one with these two. Similarly, this one with these two. Then you will get a bar b plus a bar c bar plus bc plus 0. Okay. Now just observe a bar b. Yes, this term is matching. Then a bar c here you're having, but a bar c bar is there. Okay. So this term is not matching. Here bc bar is there, bc is there, right? So that means this particular function is not self-dual. The corresponding dual function is different, right? So it is not the self-dual. Option D is not a self-dual. Okay, right. So option D is not a self-dual. Okay, right. Now, similar procedure you have to follow for option A, option B, option C. Here they have given sum of minterms because it is a function of three variables. In each product term, you're having 3 letters. That means sum of minterms. Okay, you apply the same logic and you have to verify. Similarly, here pi capital M is there, convert into sigma M, or from pi capital M only you can apply duality. Okay, from there also if you're getting whatever the original function is there, if you're getting the same thing, then also you will say it is self-dual. Similarly, here you're having sigma M, right? If you apply dual, if you're getting the same function, then you can say it is self-dual. Okay, but here if you observe, for three variable case, if you follow the same approach, then definitely it will take more time. See, here also it is a function of three variables, but you're having in each product term, you're having 2 variables only. It is very easy to analyze whether it is self-dual or not. Okay. Regarding self-dual, okay, whether the given function is self-dual or not, okay, just in order to save time, I will give one more shortcut. What you can do, when this Pade concept you can apply when you're having the function is sum of minterms, that time you can apply this particular logic. Okay, and one more thing, when you're having three variables, how many minterms you'll get? Whenever you're having three variables, how many minterms you'll get? 8 minterms, right? Okay, consider half of it. That means 8 by 2, that is 4. Okay, when your original function consists of only 4 minterms, for three variable case I'm talking, when you're having three variables, total you'll get 8 minterms, right? Out of which consider half of the minterms. Here in these three functions, option A, option B, option C, here sigma M format 4 minterms, here also 4 minterms, here pi capital M. If you convert into sigma M, you'll get 4 minterms only, right? So this is the one logic. When you're having the function having half of the number of minterms, then instead of directly apply the duality principle, whether the given function is self-dual or not, whatever the shortcut method that I'm going to discuss now, you better, with the help of that one, you will come to know whether it is self-dual or not. Okay, right. This is the first condition. What are the number of minterms you're having with the help of variables? You have to consider the half of the number of minterms, right? If you're having the functions like that, in those cases, you have to follow the second step, what I'm going to discuss now, right? So write the given function. I'm verifying option A, f of ABC equal to a bar, b bar, c bar plus a bar, bc plus AB bar C and ABC bar. Yes, this is the function he has given, right? Yeah. Now write the variables order as it is, that is ABC, ABC. Okay. Otherwise, here only I will write the corresponding bit values. A is 0, B is 0, C is 0, 0, 1, 1, 1, 1, 0, 1, 1, 1, 0. Now tell me the corresponding decimal equivalent, that is 0, 3, 5, 6. The corresponding decimal equivalent, minterm numbers, 0, 3, 5, 6. Right? See, whenever you're having one variable, for the timing, let us consider A. Okay. A we can represent with 0 or 1. Only two possibilities. Right? If A value is 0, that means A bar. If A value is 1, A, normal form. Right? See, at any time, when you are representing A with 0, that means at that time, its value won't be 1. Yes or no? Similarly, if you are considering A value 1 at any time, at the same time, its value won't be 0. Yes or no? All of you please respond. At any time, among these two values, only one value we can choose, not both at the same time. Yes or no? All of you please respond. Yes. So that means at any case, okay, if you are considering A bar, that means A won't present at that time. If you are considering A means A bar won't present. So that means these two are what? Mutually exclusive terms. Mutually exclusive terms. You might have heard this particular term in the probability, right? Mutual exclusive terms in your mathematics. Okay. So when this particular case is happening, this case won't happen. When this case is happening, this case won't happen, like that. Right? So these are mutually exclusive terms. Now whatever the values you're having, just complement, then you'll get triple one. In all the cases, for each and every value, you have to just complement. Then you'll get 100, 010, then 001, 001. Right? Now write the corresponding decimal equivalent or corresponding minterm numbers. 111, 7, 1004, 0102, 001, 1. Right? 7421. Yes. Very good, Shushma. 7421. Right? So in the given function, you're having four minterms, right? 0356. 0356 you're having. Okay, just 1 second. For 0, the corresponding mutual exclusive term is 7. For 3, mutual exclusive term is 4. For 5, mutual exclusive term is 2. For 6, mutual exclusive term is 1. Right? So here f is a function of 4 minterms. Right? For these 4 minterms, the corresponding mutual exclusive terms are this one. Right? Whether do you have any of these terms here? No, right? We don't have any of these minterms here, right? So that means here first condition is what? Whatever the function you are considering, in that particular function, you should have half of the number of minterms. That is the first condition. Half of the number of, just 1 second. Half of the number of minterms. This is the first condition. After that, the function, what is the function you are considering? There should not be any mutual exclusive term. There should not be any mutually exclusive term. Present in this particular function. If these two conditions are satisfying, then we can say the given function is self-dual. If these two conditions are satisfying, then the given function is self-dual. If these two conditions are not satisfying, then it is not a self-dual. Okay, so that means option A is self-dual. Option A is self-dual. If you want, you can verify later just by applying duality principle. Wherever logical AND is there, replace with logical OR. Wherever logical OR is there, replace with logical AND. After doing simplification, you will get the same function. I am giving as a homework for all of you. You can try to verify whether you are getting the same function or not. Okay. You will get the same function. You can verify later. So option A is the self-dual. Option A is the self-dual. Now, just 1 second. Here we got 0356. For the timing, I will write here 0356 we got. The corresponding terms we got 7421. 7421. These are the mutual exclusive terms for 0, 7, 3, 4, 5, 2, 6, 1, like that. Okay. Now write this particular function in sigma format. Sigma format, you will get 0, 3, 4, 6. 0, 1, 2, 3, 4, 5, 6, 7. Right. Now just observe 0 is there. For 3, the mutual exclusive term is what? 4. For 3, the mutual exclusive term is 4. But here 3 and 4 is present. 3 and 4 both are present. Right. So whether is it self-dual? All of you please respond. Whether is it self-dual? Option B. No, right? Since for 3, the corresponding mutual exclusive term is 4, right? So we should not contain the mutual exclusive terms in the given function, right? Yes. So that means it is not a self-dual. It is not a self-dual. Okay. Now let us verify option C. Option C. Whether it is self-dual or not. Here 0 you are having. Okay. Next. 1 is there. Next. 1 second. 0 is there. 1 is there. Then 4 is there. 5 is there. Okay. So that means whether do you have any mutual exclusive term here? For 0, mutual exclusive term is 7. For 1, 6. 4, 3. 5, 2. Right. Is it self-dual? Option C. Whether it is self-dual? Yes, it is the self-dual, right? It is the self-dual. Option C is the self-dual. So you can save the time in the GATE exam whenever you're having function in sum of minterms, right? Instead of doing in the conventional method, because it will take more time. If you follow the conventional method, it will take more time in order to judge whether the given function is self-dual or not. Okay. So you have to just consider first condition is what? Half of the minterms that particular function should contain. For 3 variables, half of the minterm is 4 minterms, right? Here in all these 3 choices, you're having 4 minterms, right? If the first condition is met, then follow the second condition, whether it is satisfying or not. Try to verify for second condition, whether it is satisfying or not. Okay. Even if you solve the conventional method also, you'll get the same answer, but it will take more time. Okay. In order to verify whether it is self-dual or not, follow this method when you're having sum of minterms. When you're having like this format, you will get the answer very quickly if you follow the conventional method. Or if you feel this method is convenient, you can follow, no problem. But provided there you should have first condition should meet. That means half of the minterms only you should have. Then only. If you don't have half of the minterms, straight away you can say that is not the self-dual. Are you understanding my point? If you don't have the vernal function, if it is not having half of the number of minterms, other than half of the minterms if it is having, then obviously it is not a self-dual function. Obviously, straight away you can eliminate because first condition itself is not satisfying. Obviously, directly you can say it is not self-dual. Is it clear, these conclusion points? If you're having any doubt, you can ask. This is very important regarding these conclusion points in order to verify whether it is self-dual or not. Both the conditions it should satisfy. Both the conditions should satisfy. All of you please respond whether it is clear or not. Yeah, you can apply for any number of bits. Any number of bits it will applicable. Suppose if you are considering for 4 bits, then you will be having 16 minterms, right? If you are having 8 minterms, then you can verify for second condition also, right? If it is satisfying, then it will be self-clear. Yeah, very good. It's clear for all of you. Yeah, next question. This is related to Venn diagrams. Here he has given 2 Venn diagrams. This Venn diagram is correspond to function f1. Just 1 second. All of you take the screenshot. The Venn diagrams are shown below. The Boolean function is given as f1 for the shaded region of figure 1. Similarly, the Boolean function is given as f2 for the shaded region of figure 2. Okay. Then which of the following options are satisfied for f1 plus f2? You have to find f1 plus f2, and here he has given 4 choices. We have to choose which are the correct options. This is also MSQ type of question. All of you take the screenshot of the question. Yeah. Now write f1 function. First observe here. You're having, this is the circle correspond to A, this is the circle correspond to B. That means this is a common area. That means intersection. When you're talking about mathematics, sets and unions, there we will say it is the intersection, common area, right? So here in terms of Boolean algebra, you can represent as what? A and B. Yes or no? Intersection of A and B. That means A and B, logical and. Okay. Now in this box, other than A, other than B, the remaining part also is there, right? So that means A bar, B bar. I'm repeating once again. This is the intersection part of A and B. So that means A and B. Okay. The rest of the area, that is other than A, other than B, right? So A bar and B bar. Now, what is F2? All of you please try. What is F2? Just tell me the term correspond to this shaded region. Yeah, Priya, you have to consider other variable also. You forget to take one more variable. See, most of the students are taking only 2 variables, but here we have to consider 3 variables. Just observe here. Here A circle is this one, C circle is this one, right? If here B circle is this part, right? We are not considering this part. Okay, so just observe here F2 is nothing but A is this one. Just observe for the time being, if you remove B circle, A circle is this much, C circle is this much. Okay, whether you are covering this part, whether this shaded region is there here also? No, right? If here also is there, then you can say A and C, but this part is not there. That means B part is not covering, right? So that means you have to consider AC B bar. Is it clear, everyone? See, if this is part also shaded one, then we will consider A and C intersection. Okay. Next, another combination is this one. Now please tell what is the term correspond to this shaded region. What is the term you will get correspond to this shaded region? All of you please respond. Correspond to this one. Yes, very good. It is A bar BC. A bar B. See, very simple. B circle is this one, C circle is this one, right? B and C intersection is there, but A part is not covering. A part is not covering. So A bar B C. Now in the question he has asked F1 plus F2. You have to add these two, F1 plus F2. So AB plus A bar B bar, AB plus A bar B bar, and here you're having AC B bar plus A bar BC. Try to observe the common terms. Try to observe the common terms. Which terms we can take common? Please identify the common terms. So from these two, I will take B as common. Just one second. I will take B as common. Then you will get A plus A bar C. A plus A bar C. Okay. From middle two, you can take B bar as common. B bar as common. Then you will get A bar plus AC. If you take B bar as common, then you will get A bar plus AC. Now apply distributive law. What you will get for here? All of you please respond. What is A plus A bar C? A plus A bar C. By using distributive law, what you will get? Similarly, you can apply distributive law here also. Yes, Srinivas. You will get A plus C. Very good. A plus C. Similarly, apply distributive law here. You will get A bar plus C. A bar plus A is 1. You will get A bar plus C. Right. Previously, we have discussed distributive law. X plus YZ equal to X plus Y into X plus Z. Right. The same formula you can use. A plus A bar is 1. You will get A plus C. A bar plus A is 1. You will get A bar plus C. Like that. Now do further simplification. You will get AB plus AC plus A bar B bar plus B bar C. Sorry, here you will get BC. Sorry. B into A plus B into C. Yeah, second term is BC. Yes. B into A, that is AB, plus B into C is BC. Right. B bar into A bar, that is A bar B bar. B bar into C is B bar C. Right. Now, AB plus A bar B bar, I am writing as it is. AB plus A bar B bar, I have copied as it is. From these two, you can take C as common. Then B plus B bar is 1. B plus B bar is 1. Right. So just observe whether this function you are having, in which choices you are having. AB plus A bar B bar plus C. Option A, right? In option A, you're having A bar B bar plus AB plus C. So option A is correct. Option A is correct. So that means option D, whether you can eliminate or not. Option D, whether you can eliminate. Yes, we can eliminate because this function, both are not same. Both are not same. Option D you can eliminate. Now, among option B, option C, we have to verify. The given function is S for P. From S for P to sigma m conversion. Right? All of you please try. All of you please try regarding S for P to P word. S for P to sigma m. Sorry. S for P to sigma m. This function is S for P form. Now you have to convert into sigma m format. Yes, very good, Tarun. Option B is the correct one. Yes. So here AB means A value, B value 1. C value can be 0 or 1. Two minterms you will get. That means 6 and 7. Next, A bar, B bar means 0, 0. Similarly, once again, C value can be 0 or 1. That means you will get 0, 1. 0, 1. Next, C value 1. C value 1. In that case, you will get 4 minterms, right? 0, 0. That means 1, 0, 1. 3, 1, 0. 5, 1, 1 case. That is 7. If any min term repeats, you can consider one time, right? So that means 0, 1, 3, 5, 6, 7. 0, 1, 3, 5, 6, 7. Yes, option B you're getting. Option B. Yes, very good. So for the given function, for the given question, two choices are correct. Option A, option B. Option A, option B. In this way, for MSQ type of questions, you have to choose all the correct options. Whichever options are correct, you have to choose all the correct options. Have you got the clarity regarding SOP to sigma m conversion and regarding self-DL? What are the concepts so far we have discussed? Up to now, we have covered the questions regarding first chapter and second chapter. That is number systems and codes, Boolean algebra and K-maps. Yeah, very good. We'll use these concepts in the upcoming chapters also. While we are solving the questions, we'll use these concepts also, right? Yeah. Yeah, just 1 second. Can you guess this is the question related to which chapter? Logic gates, right? Yes, very good. This question is regarding logic gates, related to logic gates. So this is also MSQ type of question, MSQ type of question, right? Here he has given one Boolean function, and here he has mentioned, see, this is very important. Sometimes they will mention like this, or sometimes they won't mention. If they mention whatever the assumption they have considered, we have to follow that one. Okay. If they don't mention, in general, for any logic gate, you will apply the normal inputs, right? You will apply the normal inputs only. But whenever you are getting complement version after doing simplification of any Boolean function, if you are getting the variables in complement form, you have to generate with the help of another logic gate, either NOT gate or NAND based NOT gate or NOR based NOT gate, etc. Right? But sometimes they will specify in the question like the variables are available in normal form and complement form. When they specify like this, if you are getting complement version in the simplified function, you no need to generate separately. Suppose if you are getting a bar, you no need to generate with the help of inverter, right? So directly you can use. Okay. If they don't mention anything related to the variables in the question, by default, they are available in normal form like that, right? So these are the conventions you have to follow whenever you are attempting the question related to minimum number of NAND gates or minimum number of NOR gates, etc. Right? So regarding the variables, whether they are available in normal form or complement form, what data they have given in the question, you have to observe that data. So based on that, the answer will vary, right? And here he has given 4 choices like this. Option A is regarding minimum number of NAND gates. Option B is regarding NOR gates. Option C with the variety of gates like XNOR gate, AND gate, XNOR gate, AND gate, OR gate, etc. So we have to choose the correct option. Now all of you tell me, if you are having, just 1 second. Whenever you want to implement any Boolean function, by using NOR gates, then the given function should be in which form? Then the given function should be which form? So that it will be easy for you in order to design the circuit with the help of NOR gates. All of you please respond. And similarly for NAND gates. If you are having the function in which form, it is easy for you to implement. Yeah, first one is pi cap lem, product of max terms, right? That means after doing simplification, you will get POS form. Yes, very good. After doing simplification, you will get POS. Similarly, NAND gate means SOP, right? See, originally you're having pi cap lem. After doing simplification, you'll get POS. Similarly, if you're having sigma format, after doing simplification, you'll get SOP, right? So you can easily implement by using NAND gates. Okay. Now the given function is pi cap lem. So first let us check how many NOR gates we require. And then we'll convert this function to sigma m, and then we'll do simplification, and you can check how many NAND gates we require, like that. So write the given function f of ABCD. F of ABCD. So first we are verifying for option B. First we are verifying for option B. F of ABCD is equal to pi capital M 149 pi capital M 149 1240. Pi capital M 149 1240, right? All of you draw the 4 variable K map. All of you draw the 4 variable K map and place the zeros in the respective maximum positions and do the groupings. Here the variables are A, B, C, D. Right. So here he has given max terms. So you have to place the zeros in the respective maximum positions. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right. So you're having 5 max terms. The corresponding in the corresponding places in the respective maximum positions, you have to place the zeros. Now in this case, grouping of how many zeros, how many adjacent zeros we can do the grouping, maximum number. How many adjacent zeros we can do the combinedly grouping. Grouping of 2 zeros or 4 zeros. Grouping of 2 zeros, right? Yeah, grouping of 3 zeros is not possible. Grouping of 2 zeros, adjacently placed zeros I'm talking. In powers of 2. These 2 zeros we can do grouping. These 2 zeros we can do grouping. These 2 zeros you can do grouping. Like that you will get total 3 groupings. Like that you will get 3 groupings, but in each grouping you can do the combined grouping of 2 adjacently placed zeros, right? Yeah. Like that you will get 3 groupings, right? Now write the terms for each combination. So regarding this particular grouping, column grouping, what is the term you will get? All of you please respond regarding this column grouping. This column grouping. Yes, B bar plus C plus D. Yes, very good, Michael. Just 1 second. B bar plus C plus D. See, when you do the grouping of these 2 zeros, right? C value, D value remains 0. That means C plus D normal form. Column row wise, B value 1. That means B bar, right? That means B bar plus C plus D. Yes, very good. Very good, Srinivas. Next, regarding this column grouping, regarding grouping of these 2 zeros, what is the term you will get? Regarding grouping of these 2 zeros. Yes. Yes, very good, Priya. B for these 2 rows, B value is 0. B value is 0. That means normal form B. And here column wise, C value is 0, normal form. D value 1. That means complement version. B plus C plus D bar. B plus C plus D bar. Right. Very good. What about this one? What is the term you'll get? Regarding grouping of these 2 zeros. You'll get, yes, very good, Supriya. A bar plus B bar. A bar plus B bar. Row wise, A value 1, B value 1. A bar plus B bar. Column wise, D value 0. That means D. Is it clear, everyone, how to write the sum terms? Sum terms and max terms, the convention is same. Min terms and product terms, the convention is same. Whatever the convention you will follow regarding min terms or product terms, exactly opposite you have to consider for max terms or sum terms. That's all. Whenever you do the grouping of max terms, you will get sum terms. You'll get some terms. After that, you have to multiply. That's all. That will be pivots form. That will be pivots form. So now I will write here f of ABCD. F of ABCD, that is equal to, here these three terms you have to multiply. Okay, so that means B bar plus C plus D, then B plus C plus D bar, then you're having A bar plus B bar plus D. A bar plus B bar plus D. These three terms, B bar plus C plus D, B plus C plus D bar, A bar plus B bar plus D. Now this function is pivots form. This function is pivots form. When you're having the function pivots form, it is easy to implement by using NOR gates. See, for easy understanding, I will write here. For easy understanding, I will consider two terms like this: x plus y, z plus w. This is pivots form. This is pivots form. Just for understanding purpose, I am giving one random example. Right. Here one sum term, another sum term. These two are product together, that is pivots form. Now what we will do, we will apply 2 times complement. When you apply 2 times complement, you will get the same function. You will get the same function, right? So apply De Morgan's law for inner complement. Apply De Morgan's law for inner complement. So what you will get? First term complement plus second term complement. First term complement plus second term complement and external complement as it is. Now tell me, for implement this function, how many 2 input NOR gates we require? How many 2 input NOR gates we require for implement this particular function? Yes, very good, Michael. Srinivas, yes. Vaishnavi, yeah. We require 3 NOR gates, right? Very good. We require 3 NOR gates. Just observe here, x plus y whole bar, we require 1 NOR gate, z plus w whole bar, another NOR gate, and assume this is like x1, this is like x2, x1 plus x2 whole bar, another NOR gate, right? 3 NOR gates we require. So in this way, whenever you're having pivots form, it is easy for you by implementing with the help of NOR gates. With the help of NOR gates. That's why here we have considered pivot. Yeah, very good, Shweta. So now you have to apply 2 times complement. You will get the same functionality. Apply 2 times complement, you will get the same functionality. Okay, leave external complement as it is. Leave external complement as it is. For inner complement, use De Morgan's law. Use De Morgan's law. Here you are having 3 terms, right? You are having 3 terms. Just one second. Yeah, first term complement, that is B bar plus C plus D whole bar. First term complement plus second term complement, first term complement plus second term complement plus third term complement. Third term complement. Okay, and you're having external complement as it is. External complement as it is. I hope this step is clear for everyone. You apply 2 times complement. For inner complement, use De Morgan's law. Since you're having 3 terms, each term will get complemented. First term complement, second term complement, third term complement. Since you're having logical AND, here, you'll get logical OR. Logical OR. Right? Now the question is what? Question is, you are allowed to use only 2 input NOR gates. You are allowed to use only 2 input NOR gates, right? You are allowed to use only 2 input NOR gates. Okay. Just one second. I will represent here once again. Whatever I have written earlier. Okay. Whatever the earlier step, only the same thing. Okay. Now in the question, what he has mentioned, you are allowed to use only 2 input NOR gates. In the choices, if you observe, in one of the choices, you are having 2 input NOR gates, right? So whenever you are allowed to use only 2 input NOR gates, so you can give only 2 inputs at the same time, only 2 inputs at the same time, right? So say for example, Say for example, you're having x plus y for the timing I'm considering. Okay. If you want to implement x plus y, what you will do? You will apply 2 times complement, right? So first you will get x plus y whole bar because you are using NOR gate. After that, you will use what? NOR based inverter. That means if x plus y whole bar, the same output, if you give as the input for another NOR gate, for both the inputs, same output. If you are giving, then you will get x plus y whole bar and once again whole bar. That means you will get x plus y. Yes or no? All of you please respond. Any doubt is there regarding this one? This is the OR gate. This is the OR gate or logical OR function. Since you are using NOR gate, first you will get NOR function. After that, you have to pass this particular output to one more NOR gate, which is having 2 inputs the same, right? Like that. Yes. So like that, just observe. Like that, just observe. Here C plus D is there, right? C plus D is there. So you apply 2 times complement. You apply 2 times complement. Clear? Right. Here B plus C is there. Apply 2 times complement. Apply 2 times complement. Right. See, here I am not considering B bar. I am not considering D bar. Why? The reason is very simple. Here in the question, what they mentioned, both normal and complement form available. Both normal and complement form available, right? Is it clear? Since B bar is available, D bar is available. That's why I'm not considering. So here I have put C plus D 2 times complement. Here B plus C 2 times complement. Okay, right. If you want, you can consider here also B bar plus C 2 times complement you can do, or C plus D bar you can perform 2 times complement. There is no issue. But since you are allowed to use only 2 input NOR gates, you have to consider on 2 variables like that. Okay. Similarly, here I will consider for the time being. Okay. B bar plus D 2 times complement. You'll get the same functionality. Now, whether is it completed or further we have to do any manipulation. Whether our job is done regarding NOR gates or whether we have to do further. Just observe the expression and tell me. Here the question is regarding 2 input NOR gates. Yeah. See, just observe here. Here you're having complement, right? Consider this like x1, x2, x3. x1 plus x2 plus x3 whole bar. That means you require 3 input NOR gate. But we are allowed to use only 2 input NOR gate, right? We are allowed to use only 2 input NOR gate, right? So that's why what you have to do, among any 2 terms you can consider. Among 2 terms you can consider like this. You put 2 times complement. Either you can perform here or here, no issue. Yes, very good, Srinivas. Yeah. Here the question is, since you are allowed to use only 2 input NOR gates, we have to focus accordingly. Now all of you count how many 2 input NOR gates we require. How many 2 input NOR gates we require? Yeah, yes, Priya. In the question they have mentioned the variables are available in both normal form and complement form. Since it is a function of 4 variables, A, B, C, D, normal form is A, B, C, D. Complement form is A bar, B bar, C bar, D bar. Here in the question they have mentioned both normal form, complement form available. So you no need to generate the complement version separately. If they don't mention complement form is available, then you have to generate with the help of logic gates. Yeah, we require 12 gates. Srinivas, not 8, it is 12 gates. Yes, Vaishnavi, very good, 12 gates. Just observe here C plus D whole bar 2 times complement. Here B plus C 2 times complement. Here also 2 times complement. That means 2, 2, 2. That means from here you are getting 6. Okay. After that, here 1, 2nd, 3rd, 7th, 8th, 9th, right? So from here you require 3. Next, this one is 1. Here 2 times complement, right? So from here also 3. That means total number of NOR gates required is 12. We require 12 2 input NOR gates. 12 2 input NOR gates. In the GATE exam, you won't get this much complex GATE question. Okay, just in order to get the complete idea, that's why I have framed somewhat complex. Okay. But if you understand the logic in all the possible ways, through this question, you will get all the possible ways. So if you understand this logic, so they may frame some with the help of some part of the question, right? They will ask very simple question only. They will ask medium level or easy level, not this much difficult question. Yeah, just in order to cover all the combinations, that's why I have considered like this function. Is it clear how it is 12 two input NOR gates? If you're having any doubt, you can ask. Whether any doubt is there or is it clear regarding the number of two input NOR gates required is 12. Clear? Right, very good. So that means option B is correct, right? Option B is correct. Minimum number of two input NOR gates required for implementing f of ABCD is 12, right? So option B is correct. Now let us verify option A. In order to verify option A, you should have sigma m format. After that, you have to convert into SOP, right? So now we are verifying option A. Option A. Consider the same function f of ABCD, and here he has given pi capital M 149 12 14. Pi capital M 149 12 14. Yes, all of you draw the K-map, and here in these maximum positions you will get zeros. Other than these zeros, remaining places ones. Okay. Here the variables are ABCD. First place the maximum positions as zeros, and then other than those maximum positions, remaining places you can put simply one. It is easy, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The remaining places you can put simply ones. Now you can do the grouping of ones. Grouping of ones. So you can do the grouping of these four ones. You can do the grouping of these four ones, and you can do grouping of these four ones. Grouping of four ones. Just tell me the term. What is the term you'll get for this particular grouping? What is the term you'll get for this particular grouping? We'll do step by step parallelly. What is the term you will get regarding this particular grouping? A bar C, right? A bar C. Just observe, for these two rows, A value is 0, that means A bar. These two columns, C value is 1, that means C. A bar C. Right? Yes. Regarding this particular grouping, you will get BD. BD. Just observe, B value 1 here, column wise, D value 1. Yes, very good. BD. Next. Next, you can do corner grouping of four ones. Grouping of four ones at the corner side. At four corners. You can do combinedly grouping. So from this, what is the term you'll get? By doing the grouping of four corner ones, you'll get B bar, D bar, right? See, for these two rows, B value 0. For these two columns, D value 0. B bar, D bar. Yes, very good. B bar, D bar. Next one is regarding this particular one, you are having two possibilities. Either you can do grouping of these four ones like this, right? Or column wise grouping. Like that, what are the possibilities is there? You have to do all such groupings. Whatever the possible groupings is there, you have to do all such groupings. In order to cover this particular one, either you're having this grouping or this grouping. Okay. For column grouping, you will get CD, CD. For this particular grouping, what is the term? B value is 0, that means B bar. Column wise, C value 1, C. Yes or no? Regarding this column grouping, you will get the CD. Regarding this particular grouping, you will get B bar C, B bar C. Now, among all these product terms, which product terms are essential prime implicants? Which product terms are essential prime implicants? Whether green color, whatever I have written, whether those are essential prime implicants or not. Whatever the green color terms here I have written, whether those are essential prime implicants or not. Yes, these three are essential prime implicants. Yes, very good. Essential prime implicants. CD, B bar C. These two are just prime implicants. These two are just prime implicants. Okay. So in all the minimized functions, you will have essential prime implicants mandatory. After that, other prime implicants, if we want, we will consider. Otherwise, we will ignore. Right. So first, write the essential prime implicants. That is BD plus B bar D bar, BD plus B bar D bar plus A bar C. These are the essential prime implicants. Okay. Whether we have to consider this CD or B bar C based on the context. Whatever the essential prime implicants you are having, okay, those essential prime implicants are not covering this particular one, right? So in order to cover this particular one, either you have to do this grouping or this grouping. So that means you are having choice, right? So either you can consider CD or you can consider B bar C, B bar C. So here you can write as it is BD plus B bar D bar plus A bar C. Okay. Essential prime implicants are mandatory. If all the essential prime implicants are covering all the ones, then we don't require other prime implicants. If any of the min terms are not covered by all the essential prime implicants, then in order to cover that particular one, we will consider the required prime implicants, right? So in order to cover this particular one, you're having two choices. Either you can consider this one or this one, but not both. Because you want to get the minimized function. If you want to get the minimized function, when you're able to get with the help of one particular term, either this term or this term, why we have to consider unnecessarily one more term, right? Okay. Now this one you can write as BD plus B bar D bar. You can write as B exclusion or D. Then from these two you can take C as common. That means A bar plus D. A bar plus D. Let us do parallelly for both the cases, step by step. So here BD plus B bar D bar. That is nothing but B exclusion or D. From these two you can take C as common. Then you will get A bar plus B bar. A bar plus B bar. Now, if you observe, these two functions are in sum of products form, right? Say, for example, you're having something like this. XY plus WZ or ZW. Okay. This is SOP form. This is SOP form. Okay. So, if you apply 2 times complement, and for inner complement, use De Morgan's law, you will get first term complement and second term complement, and you're having external complement as it is, right? How many NAND gates we require? How many 2 input NAND gates we require? How many 2 input NAND gates we require? 3, right? Yes, very good. We require 3 2 input NAND gates, right? Whenever you're having SOP form, it is easy for you to implement by using NAND gates. Whenever you're having POS form, it is easy to implement by using NOR gates, right? Okay. Now, so this is SOP form. So I will apply 2 times complement. This is also SOP form. You can apply 2 times complement. For inner complement, use De Morgan's law. For inner complement, use De Morgan's law, right? So B exclusion or D complement and C into A bar plus D complement, and you're having external complement as it is, right? Similarly here, B exclusion or D complement and C into A bar plus B bar, we can write as what? By using De Morgan's law, how we can write A bar plus B bar? Any idea? All of you please respond. A bar plus B bar, how we can write? By using De Morgan's law. AB whole bar, right? Very good, Srinivas. AB whole bar. AB whole bar is nothing but A bar plus B bar, right? First term complement, second term complement, and external complement as it is, right? Now just observe. Here also we are allowed to use only two input gates. Here also we are allowed to use only two input gates. Okay. So just observe here or this one. Okay. You're having something like this. You're having something like this. Say for example, XY is there. AND gate. Okay. But if you want to implement by using NAND gate, first you will get like this XY whole bar. After that, if you're passing NAND gate output through NAND based inverter, then you'll get this one, right? So this is nothing but XY. So similarly, here also, yeah, just 1 second. Here I will modify. Here I have written directly. Here also I will write A bar plus D. How we can write? A into D bar whole bar. A into D bar whole bar, right? So you can easily implement by using two input NAND gate. Here also by using two input NAND gate, right? Yes. Now this one you can write as exclusive OR, that is BXRD, and this term I will write as it is. Complement of XNOR is nothing but XOR. Similarly here also, complement of XNOR is nothing but XOR. And you're having external complement as it is, right? Now first let us verify for BXRD. For BXRD you can write as B bar D plus BD bar, B bar D plus BD bar, right? So this is SOP form. You can apply 2 times complement, right? Apply De Morgan's law for inner complement. Now tell me how many 2 input NAND gates we require for implement this particular function. How many 2 input NAND gates are required for implement this function? In the question, they have mentioned both the complemented and normal form available regarding inputs. Yes, we require 3. Yeah, very good. This first one, second one, third one. Because B bar, D bar is available, right? We require 3 2 input NAND gates. We require 3 2 input NAND gates. Okay, right. So that means for implementing BXRD, you require 3. Okay. D bar is already available, so you require 1, second, and then assume like x1, x2 whole bar 3. So that means 3 plus 3 is nothing but 6. Similarly, here also just observe how many 2 input NAND gates we require for implement this function. This one is 3. Here 1, 2, 3, right? So here also you are getting 6. Either this expression or this expression, you are getting 6 only. Okay, but if you are getting different among these two, whichever one is the least one, we will consider that one. But in this case, both are giving the same answer, right? So we require 6 2 input NAND gates. Just 1 second. We require 6 2 input NAND gates. So that means option A is correct, right? Option A, just observe, minimum number of 2 input NAND gates required for implementing f of ABCD is 6. That is correct. So regarding NAND gates, we require 6. Regarding NOR gates, we require 12. Okay, sometime in the question they will mention, instead of directly specify regarding number of NAND gates or regarding number of NOR gates, instead of that, they will mention implement the particular function using logic gates are of same type. Same type means either you can implement by using NAND gates or by using NOR gates, because these two are what? Universal gates. Universal gates. Whatever the logic function or whatever the circuit diagram you're having, the entire circuit diagram or entire logic function you can easily implement by using NAND gates or by using NOR gates, right? So among these two, whichever is the least, that will be the answer. That will be the answer. Okay, right. Now regarding C and D, which one is the correct? Let us verify. Just observe this particular function. Yeah. See, whatever the function you got here, this one I am writing here once again. F of ABCD. What is the function here? Under the 2 times complement, what is the function you're having? I'm writing here. F of ABCD. equal to B exclusion or D plus C into, or this one I will write, just 1 second, C into A bar plus D, A bar plus D. So this one I will write as B exclusion or D plus C into A D bar whole bar, A D bar whole bar. Right. Now just observe, here we require XNOR gate, we require XNOR gate. Here we require NAND gate, NAND gate, and here we require AND gate. Sorry. Here we require AND gate, and here we require OR gate. Yes or no? All the gates are 2 inputs only. All the gates are 2 input. AND gate, NAND gate, OR gate, XNOR gate. Right. Now just observe whether option C or option D, whether anyone is correct or both are correct. Is whether option C or option D, anything is correct. All of you please respond. Both are not correct, right? Both are not correct. Because we require XNOR gate, AND gate, OR gate, and NAND gate also we require, right? Just observe here. XNOR, AND, NAND, OR. But here we are having XNOR and OR only, but we require NAND also, right? So that's why option C, option D, both are wrong. So only option A, option B are correct. Yes, NAND is missing, correct. Very good, Srinivas. Yeah. Yeah, with this we have completed the questions related to the 3 chapters, right? Number systems and codes, Boolean algebra and K-maps, and logic gates. In the logic gates, with the help of this question, we covered all the variety of models, right? All the cases we have covered. So in tomorrow's class, we'll discuss the questions related to combinational, sequential, combination circuits, sequence circuits, data converters, logic family, microprocessor, etc. Right? All of you please respond whatever we have discussed. Everything is clear or not? All of you please respond. Yes, very good. I hope this session has benefited you. So please like this video and share with all of your friends so that they also can watch this lecture. This will be available in YouTube, right? So even if you also want to refer later, you can refer this particular session, right? And tomorrow we are having one more session. Don't miss that one also, right? So we are having interesting questions from the remaining chapters also. So based on the branch, actually this particular subject is, the syllabus will vary from branch to branch. So with respect to your branch, okay. So accordingly, say for example, for computer science students, up to sequence circuits only part of the GATE syllabus. For electrical students, up to data converters. For EC students, up to logic family. For instrumentation students, up to microprocessor, microcontroller, etc. That means all the chapters will be part of the GATE syllabus for instrumentation. Recently, they have removed microprocessor and microcontrollers part from the GATE syllabus for electrical and EC students, right? Okay. So with respect to your syllabus point of view, you can attend the session accordingly in the tomorrow's class. Okay. Thank you all.